Rome's most dangerous weapon was not the short sword. It was the shovel. Rome did not conquer the ancient world because its soldiers were always braver, or because its blades were always sharper. Rome conquered because when other armies saw a river, a cliff, a harbor, or a fortress wall, they saw an obstacle. The Romans saw material. A sea could become a blockade. A river could become a road. A mountain could become a ramp. A city could become a problem of timber, stone, hunger, and time. And if that problem took months, or years, or thousands of tons of earth and wood to solve, Rome would keep building until the enemy had no world left to defend. That is the hidden story carved into one of Rome's most famous monuments. In the heart of Rome, at the foot of the Quirinal Hill, a column of white marble rises about 125 feet into the sky. It was carved 19 centuries ago to celebrate Emperor Trajan's conquest of Dacia, the land that is now Romania. The column of Trajan is a war memorial. It records with extraordinary precision what the Roman army actually did during a campaign that destroyed an entire kingdom. If you stand at its base and follow the spiral of reliefs as it winds upward 23 turns, more than 150 scenes, and around 2,500 carved human figures, you will see the story of that war. And here is the strange part. Most of the men on the column are not fighting. They are chopping wood. They are digging trenches. They are hauling timber up hills. They are hammering piles into riverbeds. They are raising walls of turf and stone. They are paving roads. They are building bridges. Out of more than 150 carved scenes, fewer than 30 show actual combat. The rest show labor. The Roman army, the most feared military force in the ancient world, chose to commemorate one of its greatest victories not with men swinging swords, but with men building things. That is not how Rome usually remembers itself. We remember the gladius, the legion, the shield wall, the disciplined infantry that supposedly conquered the world by martial skill alone. But the men who carved that column knew a different story. They knew Rome's deepest weapon was not only the sword, it was the shovel. To understand how that happened, we have to go back almost 300 years before Trajan's time, to a coastal city in eastern Sicily. There, Rome first met an enemy whose weapons it did not yet understand. In the spring of 214 BC, the Roman general Marcus Claudius Marcellus arrived outside the walls of Syracuse with a combined land and naval force. He had come to take the city. Syracuse was then the wealthiest Greek polity in the western Mediterranean. It had once been a Roman ally, but during the Second Great War with Carthage, it had switched sides. Marcellus expected the siege to be hard, but he expected it to be routine. He brought a fleet. He brought ladders. He brought scaling towers. He brought a specialized floating assault platform called a sambuca. 2 warships lashed together, carrying an armored bridge that could be raised against the seawall and dropped onto the parapet. He had every reason to believe that Syracuse would fall. But inside the city was an old man. He was about 72 years old. He had grown up in Syracuse, studied geometry in Alexandria, and returned home to spend his life solving problems that most men could not even describe. His name was Archimedes. The historian Polybius, writing about a century later from sources close to the events, describes what the Romans saw. As Marcellus's ships approached the seawall, immense beams swung out over the parapet. Long timber arms, fitted with iron hooks, reached down toward the Roman vessels. They caught the prows. They lifted ships clean out of the water. Then they dropped them back. Other machines fired stones and bolts at carefully measured distances. When the Romans tried to bring the sambuca close to the wall, hidden ports opened in the masonry, and released volleys of arrows from positions the attackers had not even known existed. Marcellus pulled back. Then he tried a night attack. The machines were waiting. He tried a new angle. The machines were waiting there too. Archimedes had not simply built weapons. He had built a system. He had turned the walls of Syracuse into one calculated machine. Polybius's verdict is almost biblical. With such care and mechanical skill had Archimedes equipped the city. He writes that he terrified not only the land forces, but the naval forces as well, from unexpected quarters. Marcellus was not an inexperienced commander. He was a veteran conqueror of Gallic chieftains and Carthaginian armies. But at Syracuse, he was reduced to bewildered fury. He gave up the direct assault. He settled in for a blockade. It took him 2 years against a single city, for an ancient siege that was extraordinary. And Syracuse was not impossible to break. It had about 500,000 people. It depended on grain shipments. It was becoming desperate. But Marcellus did not defeat it with engineering. In 212 BC, during a festival night dedicated to the goddess Artemis, the watchmen on the northern walls were drunk on wine and distracted by lights and music. A small Roman force scaled the parapet. They killed the guards. They opened a gate. Syracuse fell from within. A few days later, Archimedes was killed in the streets by a Roman soldier who, according to a tradition told by Plutarch, did not know who he was. The old man was bent over geometric figures drawn in the dust. This is where the standard story usually ends. The Greek genius dies. Rome wins. The legend moves on. But the more important story is what happened inside the Roman command structure during those 2 years of failure. Because Marcellus did not leave Syracuse only with silver and statues. He left with the machines. Archimedes' surviving devices were catalogued. Greek artisans who understood the formulas were brought back to Italy. The Roman political class would have mixed feelings about the looting of Syracuse. Some senators feared that Greek luxury would corrupt the old republican virtues. But the army's response was much clearer. Rome had learned something specific. A city defended by mathematics could not be taken by courage alone, and the side that understood the mathematics first would win. This is the first thing to understand about Roman siege engineering. The Romans were not the inventors. They were the absorbers. The popular image is wrong. The Romans did not invent the catapult, the ballista, the battering ram, or the siege tower from nothing. Nearly every mechanical principle of ancient artillery had already been developed by Greek, Carthaginian, and Hellenistic engineers. Torsion spring bundles, calibrated bore sizes, geometric ratios that allowed a weapon to be scaled up or down. These ideas had been worked out in places like Alexandria, Rhodes, and Syracuse itself. The historian Eric Marsden, whose work on ancient artillery remains a standard reference, argued that Rome's genius was not invention. It was something more dangerous. Rome took weapons that had once been built one at a time by individual master craftsmen, often for individual kings, and turned them into standard military equipment. They reduced the formulas to writing. They made manuals. They embedded the knowledge inside the army itself. That mattered more than any single invention. A Hellenistic king, like Demetrius of Macedon, could field a few extraordinary siege engines. In their day, they were wonders of the world. But when the king died, or when the master engineer died, the knowledge could die with him. Rome built an institution by the late Republic. Every Roman legion contained a permanent cadre of artisans known as the fabri, the makers. There was a senior officer in charge of them, the praefectus fabrum, who answered directly to the commanding general. And every legionary was expected to use a shovel and a pickaxe as competently as he used a sword. Some men could calibrate a ballista. Some could drive piles into a riverbed. Some could calculate whether a wooden truss could bear its load. But the important point is that these men were not temporary hires. They were part of the army. Their knowledge was passed down. Their methods were standardized. Their work could be repeated from one generation to the next. The military historian Adrian Goldsworthy put it with grim humor. The Roman army was essentially an armed construction gang that could also fight. Its first instinct in a crisis was not to charge. It was to dig. The siege specialist Duncan Campbell has pointed out that this institutional structure is what separated Rome from many of its rivals. Hellenistic kings hired engineers for individual campaigns. Carthage relied on tradition and individual experts. Rome had builders inside every legion. It had manuals. It had calibration tables. It had geometric models that could be taught, copied, and reused for centuries. By the middle of the 2nd century BC, Rome had absorbed the lesson of Syracuse. Its army was being transformed slowly and deliberately. And soon, that new kind of army would be tested against a city far older, larger, and more terrifying than Syracuse. In 147 BC, Publius Cornelius Scipio Aemilianus took command of the long-stalled siege of Carthage. He was the adopted grandson of the man who had defeated Hannibal, and now he faced the city that had been Rome's great rival for more than a century. 3 wars had been fought. Carthage was a coastal fortress with double walls, naval power, and a deep-water harbor that allowed it to be supplied from the sea. 2 previous Roman commanders had failed to take it. The Senate was running out of patience. Scipio looked at the problem and made a decision that would echo for centuries. He did not assault the walls. He assaulted the harbor. His engineers began constructing a massive stone mole, a breakwater of dressed masonry, across the mouth of Carthage's harbor channel. It was construction on a scale the ancient Mediterranean had rarely seen. Boulders were ferried out by the ton. The mole grew. The Carthaginians watched as the sea itself was being closed. When their ships tried to enter or leave, Roman vessels rammed them and crushed them against the rising stones. Eventually, the harbor was sealed. Then the Romans waited. No glorious assault, no heroic charge, only famine. Slow, comprehensive, mathematical famine. By the time Carthage finally fell, its population had been reduced to a fraction of what it had been. Rome did not have to win the city in a single storm of steel. It had turned the city's own geography against it. And when Scipio looked at Carthage burning, he is said to have wept not for Carthage, but for the future of Rome. Perhaps, in that moment, he saw what his own army had become. This was the new model. The Senate understood it, the army understood it, and anyone paying attention could see the lesson. Roman armies would, when they could, choose not to fight. They would build instead. They would surround. They would isolate. They would let starvation, not steal, do the killing. And they would do it on a scale no enemy in the ancient world could match. That doctrine was about to be tested again. Not against a great Mediterranean power, not against a wealthy port, but against a small fortified town on the dry plateau of central Hispania. Its defenders had humiliated 3 consular armies in less than a decade. The general sent to finish the problem was the same Scipio who had watched Carthage burn. And at Numantia, he would turn Roman siege warfare into a template that would haunt every frontier of the empire for the next 250 years. In the autumn of 134 BC, Scipio Aemilianus rode into a Roman military camp in the high interior of what is now Spain. He was 60 years old. He had spent most of his life at war, and the problem in front of him was, by Roman standards, humiliating. The town of Numantia sat on a small plateau overlooking the meeting point of two rivers. Its population was perhaps 4,000. Maybe 1,000 of them were warriors. It was small. It was isolated. It was economically insignificant. And it had been defying Rome for more than a decade. The Celtiberian tribes of central Hispania, organized around Numantia, had ambushed 3 full consular armies. They had killed at least one consul. And in one of the worst humiliations Rome could suffer, they had forced a Roman commander to sign a peace treaty in the field. The Senate later rejected that treaty, but the damage had already been done. Rome's honor had been wounded by a town that should not have been able to wound it. So the Senate sent Scipio, the same Scipio who had watched Carthage burn. He arrived with 60,000 men against a town of 4,000. The numbers were not the problem. The problem was that earlier Roman commanders had attacked. They had charged the walls. They had fought hand to hand. They had let the defenders choose the terms of the battle, and Numantia had bled them. Scipio refused to repeat that mistake. Instead, he gave one of the most important engineering orders in the history of warfare. He ordered his army to build a wall around the town. Not a temporary fence, not a loose blockade, a continuous fortified wall, 9 kilometers long, ringing the plateau. It was reinforced by stone towers. It was doubled by trenches and stake-filled pits. It was tied into a system of camps, placed so that if the defenders attacked one point, reinforcements could reach it quickly. Then Scipio ordered the river Durius blocked. The defenders had used that river to send messages downstream. So the Romans dammed it, obstructed it, and turned even the water into part of the prison. Then Scipio gave one more order. No Roman soldier was to engage the Numantines in open combat. Rome would not give them the battle they wanted. Rome would wait. The siege of Numantia lasted 15 months. The defenders tried to break out. They were driven back. They tried to send messengers by river. The messengers drowned in the engineered obstructions. Food ran out. By the spring of 133 BC, later sources recorded reports of cannibalism inside the walls. When Numantia finally surrendered that summer, the survivors were only a fraction of the original population. Many killed themselves rather than be taken alive. Centuries later, the German archaeologist Adolf Schulten mapped Scipio's siege works with modern precision. What he found was one of the clearest archaeological records of a Roman engineering campaign ever discovered. Walls, towers, camps laid out in geometric grids around the doomed town. Numantia was not just another siege. It was the moment Roman doctrine hardened into a system. Attrition over assault. Engineering over courage. The shovel over the sword. After Numantia, that doctrine spread across the Roman world. For the next 80 years, Roman armies refined it. Every legion traveled with surveyors who could lay out a fortified camp of standard dimensions in a matter of hours. A camp in Britain and a camp in Syria could follow the same logic. Every legion traveled with sappers who could undermine walls. Every legion traveled with mechanics who could build ballistae and scorpiones from local materials. The empire expanded. The doctrine matured, and in the middle of the 1st century BC, it produced its most famous practitioner. In late spring of 55 BC, Gaius Julius Caesar stood on the western bank of the Rhine River. The Rhine was not just a river. To the people of that world, it was a wall. It was wide, deep, and fast-moving. For generations, the Germanic tribes on the eastern bank had treated it as a one-way barrier. They could raid across it when they wanted, but no Roman army had ever crossed it in force. Caesar decided that this would change. His officers suggested boats. Caesar refused. He later recorded that refusal in his own memoirs. To cross by boat, he wrote, would not be safe enough, and it would not be consistent with his dignity, or the dignity of the Roman people. So Caesar chose a different answer. He would build a bridge across the Rhine in 10 days. The man who actually made it happen was his chief engineer, a Roman knight named Mamurra. Mamurra held the title of Praefectus Fabrum. He is remembered partly because the poet Catullus hated him and wrote vicious poems about his corruption. But on the Rhine, in the spring of 55 BC, Mamurra designed something extraordinary. He built an interlocking truss bridge using paired oblique piles. 2 great oak timbers, sharpened at the bottom, were driven into the riverbed by a heavy pile driver. They were angled into the current so that the river's force pressed them together instead of tearing them apart. A second pair was driven slightly downstream at the opposite angle. Cross members were laid between them. The result was a self-tightening structure. The harder the river pushed, the stronger the bridge became. Then the Romans repeated that structure across the entire breadth of the Rhine. On the German side, watchmen gathered to harass the crossing. But what they saw was not an army crossing a river. They saw an army eating a river. Pile drivers struck in rhythm. Timbers were hauled into place. Pulleys whined. Men worked in shifts around the clock with the discipline of a machine. In 10 days, the bridge was complete. Full-weight military traffic began crossing it. The Germanic Suebi and Sugambri abandoned their settlements and vanished into the forests. There was no battle. There was no storm of arrows. Caesar marched his legions across, spent 18 days demonstrating that Rome could be wherever it chose to be, dismantled the bridge, and walked back. The message had been delivered. The Rhine was no longer a wall. This is where we need to be honest about how Rome's empire was actually built. When we imagine Roman conquest, we often picture legionaries in red tunics, shields locked, swords drawn. We picture pitched battles. We picture generals on horseback. We picture blood, bronze, and bravery. But most of the empire was not built that way. The military historian Adrian Goldsworthy has noted that pitched field battles were relatively rare. Most Roman conquests were won by siege, and most Roman sieges were not won by storming walls. They were won by surrounding a city, sealing it off, and waiting for the people inside to starve. The famous Roman discipline, the fortified marching camp, the trenches, the construction tools carried by every legionary did not exist only to win battles. It existed to make battles unnecessary. The legions did not always want to fight. They wanted to build until the enemy had no choice left. The Rhine Bridge was not an exception. It was the rule made visible. It was Rome announcing what it had become. An army that, given enough timber and enough labor, could rearrange any obstacle the world placed in its path. 3 years later, the same logic would be applied in central Gaul, and there. Roman military engineering reached its most famous form. In the summer of 52 BC, the Gallic tribes finally produced a unified resistance. Their leader was Vercingetorix, a young Arvernian noble with remarkable strategic intelligence. He had spent the campaign denying Caesar's supplies, harassing Roman columns, and avoiding open battle. By August, Vercingetorix had been forced or had chosen to take refuge in the fortified hilltop town of Alesia, in what is now central Burgundy. He had about 80,000 fighting men with him. Caesar arrived with about 50,000 legionaries and auxiliaries. A normal commander would have besieged Alesia. Caesar besieged it twice. His engineers built an inner line of fortifications around the town. The Roman term was circumvallation. It ran 15 kilometers around Alesia. Trenches, walls, towers at regular intervals. Everything was designed to keep Vercingetorix and his army trapped inside until they starved. That was already standard Roman doctrine. But Caesar knew something else. His scouts had reported that the Gauls outside Alesia were raising a relief army. If that army arrived while Caesar was facing inward, the Romans could be crushed between two forces. So Caesar built a second wall. A second line of fortifications faced outward. The Roman term was contravallation. It ran 21 kilometers around the outside of Caesar's army. Two walls, one facing the trapped enemy, one facing the enemy coming to rescue them. 36 kilometers of fortification in total. Trenches, towers, palisades, and between the walls, around them, and in front of them. Caesar's engineers created one of the most elaborate killing zones in the recorded history of pre-industrial warfare. They planted sharpened wooden stakes called cipi. These were interlocking logs with branches cut into points. Beyond them, they dug pits in a staggered grid. Each pit was just too wide to step over. Each had a fire-hardened stake driven point up into the bottom. Then the pits were covered with brush. Caesar's men called them lilia, lilies. Beyond the lilies, they buried iron caltrops, small metal spikes hidden flush with the soil, waiting to cripple any foot that came down on them. Then came another trench, then the wall, then the towers with scorpiones mounted above, ready to fire down at measured ranges. In September, the Gallic relief army arrived. Caesar claimed it numbered close to 250,000 men. The number was probably exaggerated. But the force was enormous. They attacked, but they could not see the field they were entering. To them, it looked like open ground. It was not open ground. It was a machine. Men were impaled. Men were crippled. Formations broke on pits, stakes, and iron hidden in the grass. Many never reached the Roman wall at all. Inside Alesia, Vercingetorix watched the army sent to save him die against a landscape that Rome had rebuilt into a trap. There was nothing he could do. After days of failed assaults, the Gallic relief army broke and scattered. The next morning, Vercingetorix rode out of Alesia in his finest armor. He dismounted in front of Caesar's tribunal. He removed his sword. He laid it on the ground. Gaul was Roman. By any honest measurement, it had been won by men with shovels. Adrian Goldsworthy, in his biography of Caesar, calls Alesia the moment Roman military engineering reached its first true peak. It was not a battle. It was an architectural ambush. 3 years after Alesia, Caesar's civil war against the Senate brought him to the coast of southern Gaul. The Greek-founded city of Massilia, modern Marseille, had declared for Pompey. Caesar's legate, Gaius Trebonius, was ordered to take it. Massilia was difficult. Its walls were thick. Its position was rocky. Its defenders dropped boulders the size of grindstones onto any siege team that came too close. Trebonius's engineers responded with an invention. They built a heavy shed about 60 feet long. It was framed in timber, but armored with overlapping plates of brick and clay. It resisted fire. It resisted impact. And it was just wide enough for sappers to work underneath. They called it the musculus, in Latin. That means little mouse. The name came from the way it crept slowly forward along the ground. Under the protection of the musculus, Roman sappers undermined the foundations of Massilia's stone towers. The towers came down. The city surrendered. Compared with Alesia, it was a smaller siege. But it reveals something important. The Romans were not running out of ideas. They were generating new ones at each siege. Then they wrote them down. The musculus was a custom answer to a specific problem. So were many other Roman siege devices that appear in the sources for one campaign and then disappear. Roman engineering culture had become inventive enough to solve local problems, and disciplined enough to preserve those solutions for the next generation. This was not luck. It was a body of knowledge. Around 30 BC, an aging Roman military engineer named Marcus Vitruvius Pollio tried to gather that knowledge into one work. He had served Julius Caesar in the field as an artillery specialist. Now, under the new ruler Octavian, soon to be called Augustus, he wrote a 10-volume treatise called De Architectura, on architecture. The first 9 volumes covered civilian architecture, temples, houses, water systems, public buildings. But the 10th volume was different. The 10th volume was a military manual. Vitruvius gave exact mathematical formulas for constructing standard Roman torsion artillery. He described the proportions of the ballista's core housing, where the sinew springs were stretched tight. He gave the relationship between caliber, range, and projectile weight. He explained how to calibrate the weapon so that 2 ballistae, built by 2 different teams in 2 different provinces, could produce the same result. He even recorded that the largest standard heavy stone-throwing ballistae could launch projectiles of roughly 78 kilograms at ranges exceeding 400 meters. This was what Rome had added. Not the weapon, the recipe. By the time Augustus had consolidated the empire, the Roman army possessed something no other ancient military force had ever fully possessed: a written, repeatable, standardized engineering doctrine. The fabri were no longer just individual craftsmen. They were interchangeable members of a corps. A legion in Britain and a legion in Syria could work from the same technical language. The empire was ready for its next great test. That test came in the spring of the year 70 AD, in a city perched on the Judean hills. A Jewish revolt had created the most determined enemy Rome had faced in a generation. The emperor's son and heir, a young general named Titus, was sent to deal with it. And what he and his engineers did at Jerusalem would be remembered in the surviving Jewish histories of the war as something close to the end of the world. The siege of Jerusalem began in April of 70 AD. In many ways, the city was an ideal target for the Roman doctrine. It had triple walls. It had a fortified temple complex at its heart. It had a population divided against itself, but united in hatred of Rome. And it had limited food. Titus was 29 years old. His engineers came from 4 legions: 5th Macedonica, 10th Fretensis, 12th Fulminata, and 15th Apollinaris. The siege would last about 4 months. Most of what we know about it comes from a man who was there. His name was Josephus. He had once been a Jewish commander. He had been captured by the Romans early in the war. Then he made the unusual choice to switch sides and become a chronicler. His book, The Jewish War, is one of the most vivid military histories to survive from the ancient world. What Josephus describes is engineering on a scale that, even after Alesia, feels almost unreal. To breach the first of Jerusalem's 3 walls, Titus's engineers built 3 siege towers. Each was about 75 feet tall, taller than a 6-story modern building. Each moved on wooden rollers, and each was clad on the front and sides with hammered iron plates riveted over the timber frame. That detail mattered. For centuries, defenders had used fire against siege towers: boiling oil, burning pitch, incendiary darts. Wooden towers could burn, but iron cladding changed the equation. The defenders threw fire. The fire ran off the metal and pooled harmlessly on the ground. The towers crept forward. From their high platforms, Roman scorpiones cleared defenders from the walls. Below them, under the shadow of the towers, the battering rams began to work. The largest ram had an iron head shaped like a ram. The legionaries gave it a nickname, with typical Roman black humor: Nico, the Conqueror. In May, after weeks of steady, calibrated pounding, Nico cracked open the outer wall of Jerusalem. The fighting that followed inside the city was savage. Josephus describes it with a kind of stunned horror. But the strategic point had already been made. The wall had not fallen because Roman swords were better. It had fallen because Roman engineers had built a machine the defenders could not burn. In August, the Second Temple of Jerusalem, the great structure rebuilt by Herod the Great less than a century earlier, was burned. The city was systematically destroyed. The revolt seemed finished, but it was not finished. A few hundred rebels escaped south into the Judean desert. There, on top of a flat mountain above the Dead Sea, stood a fortress that looked impossible to take. Its name was Masada, and when the Romans arrived beneath it, they did not look for a path up the cliff. They began to build one. Masada rose 1,300 feet above the desert floor. On three sides, its cliffs were almost sheer. There was only one path up. It was narrow, exposed, and easy to defend. A small force could hold it for a very long time. The Sicarii looked down from the top of Masada at the empty desert below, and they were confident. They had food for years. They had stored water, and they had a fortress that, by every conventional measure, could not be taken. In 73 AD, the Roman governor of Judea, Lucius Flavius Silva, arrived at the base of Masada with Legio X Fretensis. He looked up at the mesa. Then he did what a Roman commander did. He ordered his men to start building. The first project was a wall around the base of Masada. The Romans built an unbroken stone and earth circumvallation. It is still visible today from satellite photographs. It was just under 2 kilometers long. Its purpose was simple. No one inside Masada would escape. No one outside would get in, inside this perimeter. Silva built 8 legionary camps. They were fortified. They were geometric. They followed the same Roman logic that had shaped camps across 3 continents. Then came the ramp. On the western side of Masada, a natural rocky spur called the Leuke gave the Romans a slightly easier starting point. Silva ordered his engineers to extend it. They would build an artificial slope of packed earth and stone, reinforced with massive horizontal timbers. That slope would climb the side of the mesa until it reached the fortress wall. From the top of Masada, the defenders watched. At first, it must have looked absurd. The valley between the Roman position and the cliff was hundreds of feet deep. How could anyone fill it? A year. 10 years. Never. But the work continued, day after day. Earth was carried up. Timbers were laid inside the structure to stop it from sliding. Stones were packed and tamped. The ramp grew, slowly at first. Then, as more of the lower slope was finished and the work moved higher, it grew faster. There is a popular story about this ramp. The story says it was built by Jewish slaves captured at Jerusalem. It says they were driven up the slope under the lash, dying by the thousands, their bodies swallowed by the rising earth. It is dramatic, but it is wrong. The archaeological evidence and the work of historians like Gwyn Davies point to a different picture. Slave labor was almost certainly used for the brute work of carrying earth. But the ramp itself was Roman engineering. Its internal timber framework, its calculated angle, its stability under enormous weight. All of that required design. This was a ramp 300 feet tall, built to carry multi-ton iron-clad siege towers up a desert mesa. It stood in a region of seismic activity and seasonal flash floods. This was not improvised labor. It was a structural project. The slaves carried the dirt. The Romans designed the mountain. In the spring of 74 AD, the ramp reached the cliff. A wheeled, iron-clad siege tower was hauled to the top. It belonged to the same family of machines that had broken Jerusalem. A battering ram extended from its upper platform. The wall of Masada cracked open. By then, the defenders had already made their choice. According to Josephus, who is not there, but reports the story he was told by survivors, they chose not to be taken alive. On the last night before the Romans entered, they killed each other in a coordinated suicide. When the legionaries climbed into the fortress, they found about 900 bodies. A handful of women and children had survived by hiding in the cisterns. The Roman engineers had erased a desert abyss. About 25 years later, in the highlands of what is now Romania, Roman engineering reached its final, almost impossible peak. The Dacians were a confederation of tribes ruled by a brilliant king named Decebalus. For years, they had raided the Roman frontier along the Danube. In 101 AD, the Emperor Trajan decided that the problem would be solved permanently. To solve it, he turned to an architect-engineer from Damascus, a Greek-speaking technical genius named Apollodorus. In some ways, Apollodorus was the endpoint of this whole story. He was a Hellenistic master in the older sense, a single, brilliant mind. But he was working inside a Roman system. That system gave him standardized formulas. It gave him permanent legionary engineers. It gave him imperial budgets. And it gave him a problem. The problem was the Danube. In its lower reaches, the Danube is one of the great rivers of Europe. Wide, deep, fast, and to the Dacians, sacred. It was not just water. It was the natural barrier behind which Decebalus's kingdom was protected. To conquer Dacia permanently, Rome had to cross that river in force. Not just men, siege equipment, supply trains, the whole machinery of conquest. Apollodorus's first task was access. In the Danube Gorge, known as the Iron Gates, sheer limestone cliffs blocked movement along the river. The cliff was too vertical for a normal road, so Apollodorus's engineers carved a horizontal ledge into the rock. They drilled rows of holes. They inserted heavy wooden beams that projected outward from the cliff. Across those beams, they laid a timber deck. The result was a military road suspended from the wall of the gorge. Legions and supply wagons could now move along the southern bank of the Danube, where no army had been able to move before. The rows of holes drilled by those engineers are still visible in the cliff today. Then, in 105 AD, Apollodorus built the bridge. Trajan's bridge across the Danube was one of the most remarkable engineering achievements ever attempted in the ancient world. It had 20 massive stone piers. They were founded in the bed of a deep and powerful river, using elaborate cofferdam techniques. Temporary dry construction zones were created by driving piles in a ring and pumping out the water. On those piers, the Romans placed prefabricated triangular timber arches. The total length of the bridge was about 1,135 meters. For more than 1,000 years, it would remain the longest arch bridge in the world. The historian Cassius Dio, writing about a century later, described the bridge with open admiration. He had seen its ruins. He understood the power of the river. He understood the precision of the work. But the most important thing about Trajan's bridge was not its length. It was not the piers. It was not even how long it lasted. The most important thing was what it did to Decebalus. To the Dacians, the Danube was not merely a river. It was a kind of god, a sacred boundary, a divine barrier protecting their homeland from foreign power. Then Apollodorus's engineers drove 20 masonry piers into its bed. They spanned those piers with arches the river could not sweep away. And the Dacians understood something terrible. The Romans had not simply crossed their river. They had subordinated it. They had treated a god like a piece of geography. The river was now a Roman road. Decebalus killed himself in 106 AD. Dacia was annexed. Its gold was taken. Its people were dispersed or sold. And in Rome, the Column of Trajan was raised to commemorate the conquest. That brings us back to where we began. The column still stands in the center of modern Rome. Its spiral reliefs still climb around the stone. Scene after scene of soldiers cutting wood, laying roads, building bridges, raising walls. Now those carvings read differently. They are not decoration. They are the mechanism of Roman conquest. Not the gladius, not the famous infantry formation, not even discipline alone. What the column shows is an institution that had learned how to industrialize warfare. The Roman army was, in Adrian Goldsworthy's phrase, an armed construction gang. Its first response to a fortified enemy was not always to attack. It was to build until the enemy could no longer exist. That changed the meaning of geography. For the peoples who faced Rome, Numantines, Gauls, Judeans, Dacians, the most terrifying thing about the Roman army was not simply that it could fight. Many enemies could fight. The terrifying thing was that Rome could erase the landscape that protected you. A river could be bridged in 10 days. A cliff that looked unscalable could have a ramp packed against it. A harbor could be filled with stone. A forest could be cut down and turned into roads, palisades, and siege works. A sacred river god could be chained with masonry piers. Wherever Rome went, the world became smoother, flatter, more accessible. The natural defenses that had protected cultures for generations became raw material in Roman hands. There is another part of the story, and it is almost entirely anonymous. We know the names of a few great Roman engineers. Vitruvius, who wrote the manual. Apollodorus, who built the bridge. Mamurra, remembered mostly because a poet hated him. But most of the engineers are lost. The praefecti fabrum of individual sieges. The men who designed the Lilia at Alesia. The men who calibrated the ballistae at Jerusalem. The men who packed the structural timbers into the ramp at Masada. Their names are gone. They worked. They died. They were replaced. Roman aristocratic tradition gave credit to the commanding general. The engineer became a tool of the imperator. We do not know how many died under enemy missiles, in tunnel collapses, or while driving piles into dangerous rivers. The number was almost certainly high. But their genius was anonymous because their genius was institutional. The system mattered more than the man. And if there is one image to carry away from this story, it should not be a sword. It should be a tool every Roman legionary carried with his marching gear. The delabra, a small bronze and iron entrenching tool, half pickaxe and half adze. With it, a legionary could break ground, cut roots, hew small timber, dig post holes, shape earth. It was far more than the gladius, one of the true instruments of Roman conquest. With the delabra, an army could build a fortified camp every night. With the delabra, an army could begin the traps at Alesia, or the ramp at Masada, or the road through the iron gates. With the delabra, an army could, given enough time, dismantle the world. Rome did not master the ancient world because its soldiers were always braver. Many soldiers were brave. It did not master the ancient world because its tactics were always better. Some opponents had better tactics. Rome mastered the ancient world because somewhere between Syracuse and Trajan's bridge, It learned how to weaponize architecture. It turned military campaigns into industrial projects. It wielded the shovel, the pickaxe, the plumb line, and the calibrated artillery piece with the same lethal patience as a sword. The column of Trajan still stands today, almost 2,000 years after it was raised. The carvings have weathered. The original paint is gone, but the spiral of stone still climbs upward, scene after scene, the same story, still visible in marble. Most of the men on it are not fighting, they are building. And if you look closely at what they are holding, you can see Rome's real weapon. It is not mostly a sword. It is a shovel.